Hello. Now we will discuss next network concepts. Till now, we know what is resistor, what is resistance, sorry, and what is resistivity, and what is the role of resistance and resistivity. Resistivity is property of a material. Okay, it will be same. It will be same throughout material. Okay, at constant temperature. But what about resistance? Resistance is a parameter. Resistance is a parameter which depends on resistivity and length by area. Here resistivity is constant, and by varying length and area, by varying length and area, we can get different types of R, different sizes. Okay, and for a fixed length, for a fixed area, for a fixed row, what is the value of the resistance? Resistance will be R. That is called rho L by A. Okay. Then what happened when we deal with resistance? That means when we abstract this concept into our real network. Okay. And lumping of resistance. Lumping of resistance. We need a character which will play a role of play a role of resistance. Okay, for suppose if I want a resistance of 10 ohms, so I need a character. Simply, that means I need a actor which will play a role of 10 omega resistance. This can be obtained with the help of, we need to choose certain parameters like 10 equal to rho L by A. Choose appropriate values of rho L and A, you will get this 10 ohms resistor. And how can we get what is the rho? Rho will give the material. That means L and A will give the size. Here size and materials are again two important things. If you want a small size resistance, you have to get more resistivity value of material. If you want a large size resistor, you will take a low resistivity value. So by adjusting rho and L and A, you can make or you can manufacture the resistance, or you can manufacture a character or a device or a actor which will play a role of resistance. That character is called, and that actor is called, or the substance or the material or the device which will play a role of resistance, that is called as resistor. So resistor is a component which will play role of resistance. Okay, and what is this denoted by? This resistor is denoted by R, and units for this is ohms, and formula for that will be rho L by A, where rho equal to resistivity and L is length and A is area. Okay, now what happens if we combine, or if we want more the different type of resistors? Next we will discuss those things. Okay, and this, we know that flow of charge equal to current, that is Q by T. We know this one. And what is voltage? Voltage is W by Q. We know this one. And what is E? E equal to voltage per distance, or L also. This is E. And what is P? P equal to V into I. What is V? V equal to IR. And I equal to V by R. Then heat equal to, or heat energy, heat loss equal to I square RT, and that can be equal to V square by RT, and power equal to, we can write in terms of power equal to I square R, and power equal to V square by R. And these are all the things we know still now. Okay, next, what is a battery? Or source, or something, anything which is capable of supplying charges. We are discussing still now that the flow of charge is current. But where is this charge? We have to store charge in the form of, we need a container to store charge here. Okay, we need a container. That container is called capacitor or battery or source. Okay, which is capable of delivering charge. Okay, charge is stored in battery, right? Now what happens when we supply, or when we have battery like this? We will discuss in detail about battery later. Just for discussion purpose I am giving you. If we suppose these are the two terminals for a battery, and it is called as plus terminal and it is called as minus terminal. What happens when I connect this battery to our resistor? Which is a character is responsible to play a role of resistance, resistor R. And what happens then? This is, say for suppose this is the voltage source Vs, and voltage across R can be written as VR, and current through this can be written as IR. And applying Ohm's law, VR equal to IR into R, and IR equal to VR by R. These are the two formulas which are current through resistor R and voltage across resistance R. Of course, these are the unit volts and amps. What happens here exactly? Now we will discuss those points, some salient points here. This battery is supply energy. This battery is supplying energy to this resistor. And what happens? This charge will low like this and like this. Here the energy is released in the form of heat. What is that energy? That is I square or T heat energy. So it is energy supplying, battery delivers energy and this resistor consumes energy. Battery, that means source, deliver energy. Okay, and load, that is resistor, consumes energy. Okay, that's why energy neither be created nor be destroyed but can be transformed from one form to another form. The energy here is static electrical energy and it is transformed to heat energy by using resistor. Okay, now we know that voltage across resistor is VR equal to I into R and I equal to V by R using Ohm's law. Okay, now we will discuss our syllabus next slide onwards. What happens when I connect a battery? Battery is united by using this symbol and a resistor, and this is connected to ground and this is also connected to ground. And if I want to draw a voltage graph to this one, voltage graph, how will it be? See, up to this point, these are the differentiating points here. Observe clearly how I am drawing voltage graph for this one, for this a typical circuit, and these are the ground levels. At ground level the voltage will be 0 of course, and the capacity of this battery is 10 volts. Okay, and voltage and resistor will drop voltage always. Okay, voltage drop will be at across. Here 10 volts it is, say for suppose it is 100 ohms. Okay, now at ground level voltage is 0. At ground level voltage is 0 and at battery the voltage here it is plus, it is minus. That means the voltage across this battery is raised to 10 volts. That means, say for suppose it indicates a 10 volts mark, plus 10 volts. So voltage raised here, and up to this the voltage will be 10 volts only, and here at resistance voltage will be dropped, and again what happens at this ground level, the voltage will be 0 up to this. So here voltage will be dropped. This is voltage drop. So it is a typical curve which indicates voltage with respect voltage of this network, a typical network. Now, if I want to connect more than one resistor to get additional resistance which I need, for suppose, what is the requirement of the connection of these resistors? First, necessity. What is the objective or necessity or need of multi connecting connection of resistance? Okay, this is the thing first we need to know. Why should we connect resistors more than one? Multiple resistors should be connected. Why? Because the commercially available resistors will be like 10 ohms, 100 ohms, and 1 kilo ohm, something like this, 2 kilo ohm, 5 kilo ohm, and 10 kilo ohm, 10 mega ohm. The available resistors will be in this range only. But if I want if I want 20 ohms, how can I get? I have to utilize these resistance only, these available resistances only. So if I want the resistance which is not available commercially, I have to connect more than one resistor to make it into as per my choice. So that's why we need to know, we need to study, we need to analyze, we need to understand the multiple connections of resistors. And those connection types will be three types. Connection types. The first connection, series type, and parallel, and series parallel. In this series parallel, we will have again delta, star, and tank, and ladder. So these many types networks will be there, etc. So we have to discuss these connection types one by one. Now the first connection is series connection. And before discussing connections, let me introduce uh, two elementary things. First, what is network? Okay, network. Network is something like we can define connection of two or more elements is called network. Simply. So connection of two or more elements means if I suppose if I want to connect minus plus, this is a battery, and if I connect one resistor here, say it is R and it is B, this is a network. And if I connect one more thing like this is also a network. Okay. Then what is circuit? What is meant by circuit? If a network contains at least one closed path, then it is called circuit. Simply. See here, Here there is a closed path. That's why it is network and circuit both. And whereas in the second case, see here, this is only network but not circuit. And in the third case, if you observe, here it has one closed path. Of course, here no closed path. Of course, as per the definition, it has to have at least one closed path is enough. So that's why it is network and circuit. And from this, we can say note all the circuits are networks. Okay, but all the networks need not be circuits. Okay, then junction, we need to know junction or node. Okay, junction or node can be defined as connection of two, connection of it is a point connecting more than two elements. Okay, suppose if I have a network something like this, here is a point but it is not junction. Here is a point, here is a point connecting here two elements only, but if I connect one more element here, one, see, observe here, here 1 2 and 3, so it is a junction or a node. Okay, next, what is meant by branch? Simply we can say that every element is called as branch or branch connecting two nodes or two elements. We can define any way. I will give you the examples for this so that it will be very clear for you. Say this is one element, okay, and this is another element, this is another element. I have defined every element is called as, the first definition is every element is called as branch. That means it is a branch, it is a branch, and it is a branch. So the first definition is valid. And second definition is connecting two nodes. That means, for suppose if I have one more element like this is a node and this is a node, right? So connecting these two nodes will be a branch. In this case, this is node and this is node 1 and node 2. Connecting these two nodes, that means here no element is here no element, but it is branch. Why? It is connecting two nodes. Okay, it is connecting two nodes. And one more, third definition is connecting two or more elements, or two elements simply. See here, this is one element and this is one element. Connecting these two elements, the third one will be a branch. Okay, in this way we can define branch in three ways. Now we will define connection types, right? Our main content. And the first connection is series connection. Series connection. I can define the type of series connection as a series connection that if current through two elements is same, then those two elements are said to be in series connection. What exactly it is? Suppose if I have element A and element B, okay, and from here element C and element D here. Here we know that by seeing this one, the current through B, A and B is same, right? That's why the current through A and B are same. That's why it is called as A and B are in series. And what about C? C, for suppose if I divide this current as, say this is I1, and as it is node, the current will be diverted here like I2 and I3. So the current through A is I1, B will be I1, and C I3, D it is I2. Here current through two elements A and B is same. That's why A and B are said to be in series. Okay. And specifically, if we want to discuss about series connection of resistors, okay, let me assume two resistors R1 and R2 connected in series. Okay, say it is battery, the voltage is Vs as it is source R1 and R2, and I can draw in this R1 R2. The current will be same throughout loop, and voltage across R1 is V1. The current through the loop is I, and voltage across R2 is V2. Okay. Now, as per the law of conservation of energy, we can give you the statement that law of conservation of energy neither be created and nor be destroyed. So, the energy supplied by Vs equal to energy supplied to R1 plus energy supplied to R2. And in a given time, energy equal to P into T. So at a time t, for a duration of time t, it can be written as P source into T equal to P into R1 into T plus P in R2 into T, and T are get cancelled. So that is PR1 plus PR2, and it can be represented as the current is same, I can write power in terms of current. So that is I square R1 plus I square R2, here I square R, okay, and I square are get cancelled. I got R equal to R1 plus R2. Okay, where the first equation, where could we adopted this equation, from where? It is law of conservation of energy. Okay, law of conservation of energy. What happens if I connect more than two elements? If I connect more than two elements, R1, R2, R3 and R4, current will be I, and V1, V2, V3 and V4. I can write it as R equal to R1 plus R2 plus R3 plus R4 similarly. And if n resistors are connected, take it as a note. If n resistors are connected in series, what happen? That is R equivalent can be written as R1 plus R2 plus up to Rn, and that can be written as summation over I equal to 1 to n Ri. This is the equivalent formula for series connection of resistors. Okay. Next, what about the voltages? We will see that thing. And I am taking like the same circuit, I am connecting in a different manner. Of course, I already gave you R1, or simply, sorry, I made a mistake. Minus plus. And if I want to draw voltage, for this one. Observe what will happen. See, this is the connecting terminals for resistors R1, R2 and voltage source. Okay, we know that the ground is at zero level potential, that is a standard notation. Okay, and battery is, say for suppose it is at 10 volts. Okay, and at this point it is at 10 volts. So there is voltage rise across capacitor, and it maintains same level up to this, but resistor will drop a voltage up to say some level here, and it will maintain the same level up to R2, and again it will become here. This is from here to here, the drop due to R1, from here to here, drop due to R2, and combining both resistances will be equal to these two, will be equal to the source resistance 10 volts, and we will derive the relationship between those things in the next slide so that you can understand. Ten volts or simply Vs, you can put it Vs. Okay, and it is R1, R2. Okay, and the voltages will be, voltage across R1 will be V1 and R2 will be V2. The current is current will be same. Now we know that R equal to R1 plus R2, and what about the total current I equal to Vs by R, and that equal to Vs equal to Ri, and Vs equal to R is R1 plus R2 into I. Okay, that implies Vs equal to I into R1 plus I into R2. We know that IR is voltage across resistor VR. Yes, so from this relation Vs can be written as VR1 plus and VR2. Right? It's a very good relation. Okay, and from this we can define another very useful theorem, that is voltage divide rule. Now observe this network. Okay, current is same, R1, R2, these are the drops V2 and V1. Now we just now derived that V1 equal to R1 into I, right? What about I? I equal to V, the source, Vs divided by R1 plus R2. And this can be written as V1 equal to Vs into R1 by R1 plus R2. And I can say that V1 equal to a fraction of something like Vs divided by 1 plus R2 by R1. That means Vs is divided with the 1 plus R2 by R1. This is called dividing of voltage. And similarly, V2 can be written as Vs divided by 1 plus R1 by R2. So this is called voltage division. What happened here? Here the main voltage is divided into two fractions. One is V1 and another is V2. That equal to V1 equal to Vs by something like 1 plus R2 by R1 and V2 equal to Vs by 1 plus R1 by R2. This is called voltage division. This is called voltage division formula. And now I can generalize this voltage division. I can generalize for suppose if any voltage source Vs is connected to a number of resistors up to n resistors R1, R2 and so on Rn. So any voltage Vk can be written as Vs into that particular Rk divided by sum of resistors connected in series I equal to 1 to n Ri. This is a generalized formula for voltage division. Voltage division is possible in only series connected resistors. Voltage division is possible, or we can say in the textbook language applicable to only series networks. Okay, in the series networks, because the key point here is in series networks. In series networks, what about current? Current is same. Current is same. So current can't be divided. Current will always be same. So the only thing available to be divided is voltage. So in series connections, current is constant and voltage can be divided. That is the way. And if you have any queries, you can mail to Krishna Electrical Tutorials at gmail.com. Okay. Thank you all and all the best for your exams.